So this is kind of easy to see. You got negative 16 t squared feet per second, that's gravity, plus 18 or 1600, that's how high we are. Alright. And I want to know how long it'll take the package to hit the ground. And in our equation that we're given, h is height, t is time. You guys don't really have to write this down. It's the first. You just pay attention. It's that first problem on the worksheet. Actually, I'll just give you the worksheet on that. Yeah, it's not like. Well. Alright, so how do you think we could solve how long it would take to package in the ground?
Most late feet of 1600 feet.
Yeah, well, 1600 feet is our starting height. If we use equation, so basically the equation is saying we can plug in a time, like say 5 seconds. If we plug in t equals 5, we'll find out how high the package is after 5 seconds.
Oh.
Okay. So if we plug in 0, it'll be at 1600 feet. So after 0 seconds, we're at our starting point. So we're trying to find out how long the package is on the ground. What? Yeah, or you could guess and check. It's always an option. But if we want to just solve right out how. So h is height. So high. We start at 1600 feet when time is 0. How high off the ground is the ground? What? Weird question. You should be a weird answer. Yeah. So the ground is 0 feet off the ground, right? That makes sense. If you're on the ground, yeah. So if you're on the ground, you're already on the ground. Less than 1%. Yeah. So we're trying to find, we want to find t when we're 0 feet off the ground. So we can set up this equation. Alright, so we're trying to find how long, we're trying to find what t is when h is 0, basically. So h is height, so if we're 0 feet from the ground, we're on the ground. So we'll set up the equation like so this equation, we're going to solve for whatever t is, will tell us when the package reaches the ground. So 0 feet off the ground. If we want to find out how far, if I want to find out how long it's going to take to be 100 feet from the ground, or 6 feet from the ground, so I can just catch it in my hands, I would just plug in 6, or whatever height we're looking for. And same thing yesterday. Yesterday we were trying to find out that dolphin had a projectile this, and if that was a graph, we're trying to find that point when we're 0 feet from the water. I draw my dolphin again. I was practicing yesterday.
Practice? I can't tell. Not you worse.
How many unicorns do you know that have a flipper in the back? So, but this time instead of a dolphin, we're using a helicopter. We're dropping this.
That's a fish.
That's a whale.
It's not done.
Oh, not bad. It's not bad.
That's a whale.
That's
a whale.
You gotta give it the full like landing thing on the bottom. Put your hands up.
Right. But what I'm doing is I'm throwing just lots of calculators from
What is that?
How is it going to the right?
How is it falling this way?
Because I'm guessing the helicopter's moving, so we're fine. We're going like 10 miles an hour or something. And then the wind obviously picks up the parachute.
So you're going backwards.
That looks like a mushroom.
You're going backwards in the helicopter.
Well, no, we're going forwards, but we throw the, if you're ever like driving in your car and you throw, that's fucking out.
Right, but it's
You
gonna
never walked in, so you're moving and you drop something.
If you throw something out, it goes faster.
Yeah, alright guys, let's look what I'm wrote down here. Alright, I drop it right here, the helicopter keeps moving, this is the point in time. So if you're flying and you drop something, it drops, it kind of goes, it doesn't drop straight down.
Yeah, it doesn't go back.
Well, well, the helicopter's still moving. I can't do an animated video here.
Just draw an arrow in front of the helicopter and show that it's going.
Alright, so we're trying to find out, we're at 1,600 feet up here. Alright, this box is moving at we're going to use h equals negative 16t squared plus 1,600. That's the movement of the box. Alright, so right here the height is 1,600, down here the height is 0. And we're trying to find out what t is going to be, what time it is. So how long does it take to go from this point to this point? And that's why we said it equals 0. So how do we solve this? Yeah, what's the G? Is there a GCF? 16. Yeah, I'm going to pull out negative 16 because no one likes negative numbers. You like negative numbers? Alright, so I'm going to factor out 16. And I'm going to be left with, or negative 16. I'm going to be left with t squared. I took out a negative, so the plus is going to become minus. And then what's left? Alright, so now that negative 16 is going to hang around for a while. Alright, what's next? How can we factor this further? No? Yes? No? Why not? There's no common factors, but are there two terms? Is t squared a perfect square? Is negative 100 a perfect square, or minus 100? Yeah. So we can do difference of squares. Right? So we got. Alright, we know t squared is a perfect square. So we know it's going to be, or we know this is the difference of squares. So we're going to have two sets of parentheses. Okay. You guys already told me t was a perfect square. Alright, what times what is t? Or what times what is t squared? T. Right. So you know it's going to start with t. What times what is 100? What times itself is 100? 10. So, technology, right? Right, and then it's difference of squares, so we know signs are going to be opposite. Plus, the one on your quiz was like x squared minus 25. Alright, so now we have a factor. Alright, now we're in factor form. When we were solving, you didn't have to do this on the quiz. What did we do? It's the third or fourth step. So after we factored in the two binomials, what did we do when they're equal to 0? we set each factor term equal to 0. So we kind of split this up. So I'm going to split the 3 terms I have and set all of them equal to 0. Alright, so I'm going to set 0 equal to 16. Negative 16. I'm going to set 0 equal to t plus 10. And I'm going to set 0 equal to t minus 10. And I'm going to solve for t in each of these, right? Alright, just equals c? No, alright, so that right away doesn't work. What about the other ones? What's c going to equal? Yeah. So if 0 equals t plus 10, t has to be negative 10. And over here, 0 equals t minus 10, so that means t over here has to be positive 10. So now we have 2 answers. So does it make sense that we drop this package and it hits the ground after negative 10 seconds? No, it can't. I don't know, do you guys know how to drop it back in time? Alright. Maybe you do, let me know. So this answer doesn't make any sense. You can't have negative time. So our only answer that doesn't make sense is 10. Alright. So to answer our question, yeah,
What I did was, I had negative 16 equals 0, and then like the second step, and then I had t squared equals 100, and I just square root it.
yeah, you can do that too. Yeah. So that's all we have, right? We've got factoring. Alright. So alright. So back to our problem. How long does it take to pass the ground? 10 seconds. So let's see. So I want you guys to try maybe the second one. Second one on your worksheet says the height of a flare from a deck of a ship in distress can be modeled by that equation, where h is height, t is time in seconds. We're trying to find out how long it takes a flare to hit the water. So h is height, what height is it going to be at the water? Yeah, so this would be set equal to 0 again. This is an experiment too. I found out I could record that. I'm making a website where I'm just going to upload it on my notes. But, yeah. So like I'll stop this.